All right, Chapter 9, Review Test. This is for exponents and logarithms. Number 1, if 10 grand is investing, earning 6% annual interest, compounded quarterly, what will it be worth after 8 years? All right, so this is an investment problem. So you need to use the formula A equals P times the quantity of 1 plus R over N to the power of N times T. All right, so what will it be worth is your accumulated amount. Okay, so what it will be worth is going to be the value for A. And the principal, the amount invested is 10 grand. So that is going to be the value for P. All right, 6% annual interest is your interest rate, but you need to convert it to a decimal. So if you move the decimal 2 places to the left, that's 0.06. And compounded quarterly, well, if the interest rate is in terms of an annual interest and it's compounded quarterly, how many times is quarterly compounded per year? Well, that's 4. All right, there's 4 quarters in a year, so N equals 4. And finally, the time T equals 8 years. Okay, so that's going to be your value for T. That's going to equal 8. All right, so we're trying to solve for A. The principal amount is 10 grand times the quantity of 1 plus the interest rate, which is 0.06, and that's divided by 4. Okay, the way I remember this formula is that the interest rate always has to be divided by the number of compounding periods because it's 6% annually. But if it's compounded quarterly, you need to divide it by 4. And that is times N, which is 4, times T, which is 8. All right. And really, you can do this on one shot on your calculator, and I would round to 2 decimal places like the answers, because we're dealing with dollars and cents. All right, 16103.24, that is answer B. Number 2, what is the present value of 50 grand due in 10 years, earning 8% annual interest, compounded annually? So for present value, you can still use the same formula that you used in problem 1. Okay, it will still work. But if you want a little bit of a shortcut, if you just reverse the A and the P and make the exponent negative, that's the present value formula. So if you swap the A and the P and make the exponent negative, it should work. All right, so the present value P equals the accumulated amount A times 1 plus R over N to the power of negative NT. All right, if you left this positive, this would grow beyond the accumulated amount. Okay, the present value P should be less than A. So this exponent is negative. You're actually dividing by this whole thing. Remember, when the exponent is negative, that means this whole thing is basically in the denominator. Anyhow, the present value is the one we're looking to find. 50 grand is the accumulated amount. 10 years is the time. The interest rate is 8%, which is 0.08. And compounded annually just means that it's compounded 1 time per year. All right. So the N in this problem is actually unnecessary, but I'm going to leave it in just to show you. All right, the accumulated amount is 50 grand. And that's times 1 plus the interest rate, which is 0.08, divided by n. And that's times negative n, which is 1, times t, which is 10. All right. So really, if you want to, 0.08 over 1 is just 0.08. You can eliminate that, and you can eliminate the 1 here. But make sure you leave your exponent as negative 10. So this is 1 plus 0.08. It's basically 1.08 to the power of negative 10. Okay, 50 grand times that right there. All right. All right, 20,159.67. That is answer C. Number 3, rewrite log base A of x equals W as an exponential equation. All right, so log base A of x equals W. We want it as an exponential equation. We want the log to cancel. So what can we do? Well, right here is log base A. So I'm going to make this whole thing the exponent on the number A. All right, and since I did that to this side, I need to do that to the other side as well. So this part in red became the exponents. And now A and log base A cancel, because when you have a number raised to an exponent, that number is the base. This is the base of the log. So the A and the log base A are gone. We are left with x equals A to the power of W. And that is answer A. X equals A to the power of W. All right, number 4. Now we're going the other way. We're rewriting the exponential equation as a logarithmic equation. All right, 7 to the m equals n. Okay, I am going to leave some space because since I'm going to make a logarithmic equation, I need to take the log on both sides. Okay, again, when you have something raised to an exponent, that number is your base. So since we have a base 7 here, I am going to do log base 7 on both sides. All right, log base 7 and the 7 cancel since the bases match, and we are left with m equals log base 7 of n. All right, we're just left with the exponent m, so I wrote it on the other side. M equals log base 7 of n. That is answer D. Number 5, e to the ln of 7. I'm pretty sure that's just 7. Let's double check. Let's make sure we know that the natural log is the same as log base e. All right. So therefore, I am going to rewrite the ln as log base e. So we have e, and instead of ln of 7, I'm going to make it log base e of 7. Okay, and now it's obvious. This is a base, and this is a base. The bases are both e's, so they cancel, and you are just left with the 7. That's answer B. All right, nothing else comes close. Number 6, they want us to rewrite this expression here as a single logarithm. All right, let's see. I would say the first step is to make the number out front into the exponent, okay? Because we're trying to condense this. So the exponent or power rule should be the first step. This is 2 times ln of y. The 2 is the coefficient, and I could just make that the exponent on the y. So that would be my first step. All right, so we are left with ln of x. Keep the negative sign, and that's going to be ln of y squared. And that's going to be plus ln of z. All right, so we did all the power rules. That was the only number out front. And now right here, we can do the quotient rule since we're subtracting. We have ln of x and minus ln of y squared. So that's going to be ln of x divided by y squared. The one that's being subtracted goes in the denominator. So that's x divided by y squared. And now we have plus ln of z. All right, so when it's negative, you do the quotient rule. And now when it's positive, we're going to do the product rule. We're going to multiply x over y squared times z for the final step. So that's going to be ln of x over y squared. And if just before you write this down, if you wrote times z, that z is, well, I'll do it in two steps. That times z, the z is basically in the numerator. All right, that z is a numerator. So it's really just ln of xz over y squared. Okay, you really don't need two steps at the end there, but I just did it just to show you. All right, so ln of xz over y squared is clearly answer A. All right, so when you write it as a single logarithm, to condense it, you do the power rule first, and then you can work on the quotient and product rules from there. Number 7, expand the logarithm. Okay, let's see what we have here. We have a log base 5. All right. And since the root of this fraction is 3, I'm going to rewrite the fraction. Keep the inner part, ab squared over c. And that fraction is going to be raised to the 1/3 power. Okay. Because the root on this radical is 3. And you could say the exponent on this whole thing is just 1. So remember, the exponent goes in the numerator and the root goes in the denominator. Anyhow, a cube root, that's the same as 1/3. All right, remember exponent or power rule. This exponent is applied to this entire argument here. So this 1/3 can go to the front of the log. Okay, so that's 1/3 log base 5 ab squared over c. Now let's see what we could do here. I'm thinking a product rule and a quotient rule. Keep the 1/3. All right, because 1/3 is times this whole thing right here. So we can just keep the 1/3 and do the product and quotient rule right here. All right, let's put our brackets in. We have a log base 5. And if you have a times b, or a times b squared in this case, that's going to be log base 5 of a plus log base 5 of b squared. All right, because these are multiplied, so you expand them as such. And since it's divided by c, that part is going to be subtracted. So it's going to be log base 5 minus log base 5 of c. Hopefully that does it. Let's check their answers. All right, let's see. 1/3 log base 5 of a. Okay, one more step. Let's see. The final step, I really don't feel like rewriting this whole thing. The final step on this one, you apply the exponent rule again, and the 2 would go out front like so, and you can just cancel this 2 here. So that's what they have, 1/3 on answer D, I think it was. 1/3, and they have the brackets, log base 5 of A, 2 log base 5 of B, minus log base 5 of C. So that's what we got. Okay, we had to do the 1/3 first. All right, the only other option is to start distributing the 1/3, but I wouldn't do that. Okay, just move it out front and use the brackets and then work with what's inside the brackets. Okay, so we couldn't use this power rule until the very end, until we unpacked all this here. But this power rule we used right off the bat to get rid of the 1/3. Number 8, solve for x. Okay, pretty simple. Log base 6 of x minus 1 equals 2. Now, just like before when we unpacked the log and made it exponential, same thing here. This is log base 6. I am going to use this as the exponent on the number 6, because now this base matches this base. Whatever I do to the left, I want to do that to the right as well, the number 6. Okay, 6, log base 6, that's gone. We are left with the exponent of x minus 1. And of course, 6 squared is 36. Simple from here. If I just do plus 1 on both sides, the 1 minus 1 is gone. And x equals 37. That is clearly answer B. All right, number 9 is a little bit of work. They want us to solve for x. So, I am going to combine these two using the power rule. We have log base 4 and log base 4 and a plus sign in the middle. So that's going to be log base 4. And since there's a plus sign in the middle, we are using the product rule. Okay, maybe I said power rule, product rule, because there's a plus sign. X plus 1 and x minus 1. And that equals log base 4 of 8. All right, now that these are combined, you can see we have log base 4 and log base 4 on both sides. So we can just take the argument on that log base 4 and set it equal to the argument of log base 4 on the other side. So this equals 8. Okay, I can see already this is a quadratic. And a quadratic has to be set equal to 0. Okay, I'm going to unpack this and set it equal to 8. So let's use FOIL. All right, x times x is x squared. Inner outer, plus 1x minus 1x. That cancels. And the last term, positive 1 times negative 1 is negative 1. And that is going to equal 8. All right, we lucked out on that one. Since there's no x term, okay, we can just move the other term to the other side. We have an x squared, but that's it by itself. So we can do plus 1 on both sides. We don't have to factor or use quadratic formula. 1's cancel. X squared is 9. Taking the square root of both sides. All right, when you do the square root of both sides, you need to do plus minus. So x equals 3, but it also equals negative 3, okay? Because negative 3 squared would give us 9. Now we have to test. All right, we have to plug them in. So let's go back to the original. All right, we have 3 and negative 3. If I put a 3, remember the thing you're taking the log of has to be positive. If I put a 3 in there, 3 plus 1 is 4. That's okay. 3 minus 1 is 2. That's okay. So far, so good. If we put negative 3 in, negative 3 plus 1 is negative 2. You cannot take the log of a negative. All right, so negative 3 fails the test. And the final solution is only x equals 3. All right, so the thing you're taking the log of, which is called the argument, that has to be positive. All right, so if you plug in a number and it's not positive, that's not going to be a solution. All right, so x equals 3. We can see that is only answer C. All right, don't fall for the trap of plus or minus 3. This is just answer C by itself. Number 10, what is the domain for f of x equals log of x plus 4? That's easy. We said it in the last problem. The thing you're taking the log of has to be positive. All right, so x plus 4 is greater than 0. Not greater than or equal to, just greater than 0. Minus 4 on both sides. X is greater than negative 4. All right, on a number line, what does that look like? Well, if you have negative 4, and it does not include negative 4, and it's everything greater than it, you are just shading everything that is greater than negative 4. Okay, so the interval notation, it does not include the negative 4, so use the rounded parenthesis, and it runs all the way to positive infinity. Okay, for infinity, you also use the rounded parenthesis because it's not an actual number. All right, so that is clearly answer C. Number 11, solve for x. 3 to the x plus 1 equals 15. Now, you can definitely do the log on both sides. Okay, if you want to do it that way, that's fine. But since we have a base 3 right here, I am going to use log base 3 on both sides. All right, if this had an exponent with an x in it as well, it wouldn't make sense to use log base 3. All right, you would use log or natural log. But in this case, 3 and the 3 cancel, and x plus 1 equals log base 3 of 15. Using the change of base rule, we're going to do log over log. And remember, the base goes on the bottom. So since it's base 3, that goes on the bottom, and that means the 15 goes on the top. All right, and finally, the opposite of plus 1 is minus 1. You do that to both sides. All right, and luckily, their answers are in that form. So it's log 15 divided by log of 3 minus 1. And right here, negative 1 plus ln of 15 over ln of 3. Otherwise, if you want a decimal answer, you go to the calculator. All right. If you did log of both sides, it still works. Okay, you'll get the same thing. Or if you did ln on both sides, you'd get the same thing. Okay. These logs have to match when you use change of base rule. So it doesn't matter if it's ln or a regular log. Same thing. Number 12, how long will it take for investment to double? If it earns 10% annual interest, compounded quarterly. Okay, how long will it take is going to be a time. And if it has to double, that means if you invest P and you want it to double, the accumulated amount is going to be 2 times P. All right, remember P is the principal that you invest. 10% annual interest, the rate is going to be 0.10. You move the decimal over 2 places. Compounded quarterly, that is 4 times a year. So N equals 4. Okay, if they give you the annual interest, compounded quarterly means how many times annually, how many times per year, so it's 4. All right, so we're trying to make the investment double. We'll use our accumulation formula. The accumulation is the principal times 1 plus the interest rate divided by the number of periods compounded to the power of NT. All right, we are trying to solve for T. So A is going to be 2P because we want it to double. P is what we invest. So A is going to be 2 times P. And that equals P to the times the quantity of 1 plus R, which we said was 0.10, divided by N, which we said was 4 because it's quarterly, to the power of N, which we said was 4, times T, which we do not know at this time. All right, so we want to isolate that exponent, T. We need to do the log on this and use the power rule, but we have this P in the way. What do? Since it's times P, do the opposite. Just divide both sides by P. Cancels here, cancels here. P divided by P. We're left with 2 equals, leave some space, 1 plus 0.10 divided by 4 to the power of 4t. You can use log or natural log. It does not matter, okay? If there were an E here, natural log is much better. But in this case, it doesn't matter. All right, I'll use natural log since I used the regular log on the other one. All right, do natural log on both sides. Power rule. The exponent 4t is moved to the front. All right, so we have ln of 2, and that equals 4t times ln of 1 plus 0.10 over 4. These are all multiplied. This is 4 times t times ln. The opposite of times is divided by. So since it's times, we're looking to solve for t. Since it's times 4, I'm going to divide it by 4. Since it's times ln, I'm going to divide it by ln. All right. So this is 4 times ln in the denominator. Do that to the other side. 4 times ln of 1 plus 0.10 over 4. On the right, 4 over 4 is gone. ln of this, ln of that, same thing. We're left with t. I'm going to go to the calculator on this. And I get 7.02. All right, remember units have to match. And the interest rate was annual. That means per year. Okay, so the time t is also going to be in years. All right, so that is 7.02 years. Close enough. Answer D, about 7 years. Last one, half-life of a substance is about 40 years. What's the annual decay rate? All right, this is a population decay. That is going to be n of t equals n sub 0 e to the negative rt. If it were growth, it would be positive. All right, and remember, this is still just the same as the banking formula, investment formula, when it's compounded continuously. A equals PERT, except it's a decay, so it's negative RT. Same thing. All right, if it's easier to remember, A equals PERT, that's fine. Anyhow, half-life means you get half of the original. The original is n sub 0, so half-life is going to be half of n sub 0. And that equals the original, n sub 0, times e to the negative r. Okay, the rate is what we're looking to find. And t is 40 years. So in place of t, 40 years. All right, we have n sub 0 on both sides times n sub 0. Let's get rid of it. I'm going to divide both sides by n sub 0. Cancels, cancels. We're left with the e. All right. Actually, before I go to the different color, let me rewrite 1/2. And that equals, leave some space, e to the negative r times 40. So that's negative 40r. How do we isolate that exponent? Well, we need to do log on both sides. Should we do log or natural log? Let's do natural log because we have an e. All right, natural log on both sides. This is log base e. This is a base e. So those cancel, and you're left with the exponent. All right, ln of 1/2 equals negative 40 times r. The opposite of times negative 40 is divided by negative 40. All right, the negative 40s now cancel, and we are left with the r. This is your r right here. Let me go to the calculator. Rounding off, 0.0173. Their answers are in percent, so we have to convert it. You move it over 2 places, and that means r is approximately 1.73%. The time t was in years, so this is 1.73% per year. That's how fast it decays. So I am going with answer C, because that is the closest to 1.73. In this step, if you had done log on both sides, it would still work. But you'd have extra work because log of e would not cancel. ln of e cancels.